Okay, so this is the quiz that we took today in Dr. Butcher's class. I'm going to go through these problems one by one, and I may over explain a little bit just to make sure that all of the bases are covered. So in question 1, it says lithium hydroxide is a monoprotic strong base. And what we need to remember is monoprotic, when it comes to bases, means that it's going to take on it's going to make one hydroxide, okay? So lithium hydroxide, being a strong base, it's going to fully ionize. So that means when you put it in solution, it's going to make lithium ion, lithium plus 1, and then your hydroxide, which is going to be minus. And your whole amount of lithium that you add is going to turn into hydroxide ions and lithium cations. So we need to know what the pH of this molarity 0.00046 molar lithium hydroxide is. This is a pretty straightforward problem. We do not have what we need to get the pH, because if you'll remember from our pH formula right here, we need the negative log of our hydroxide ion to find pH, or we can find our pOH and subtract the pOH from 14 to get our pH, and that is exactly what we're going to do here. So in order to find pOH is going to equal the negative log of our hydroxide concentration, which we have because that is going to equal what our molarity is, because this is a strong base, so it fully dissociates. And I'm going to grab my calculator and we're going to plug it in. All right, the calculator has been found. So we're going to do negative log of our hydroxide, which is 0.00046, enter, and that's going to give us our pOH. So our pOH is equal to 3.337. But remember, we're trying to find pOH, so we've got to take 14 minus our pOH, and that's going to give us our pH. So on my calculator, this is why I really like this model. We're just going to do 14 minus answer, and that's going to give us our pH is equal to 10.66. And that is question number 1 solved. All right, question number 2 is a bit more involved. It has 4 parts. So weak acid HC has an acid dissociation Ka value of blah blah blah. What is the pH of this? So first we're going to write out our reaction. So we've got HZ, and that is going to dissociate into H plus Z minus. Okay, and then we're going to write out our Ka, what that is going to equal. That's going to equal the concentration of hydroxide times the concentration of our Z minus. And that is going to be over our concentration of our HZ, if I can write. And then we're going to minus X, which we can discard that. Our X is going to be negligible, because if you'll remember that if X is less than 10 to the negative 4, if it's smaller than that, then you can just say that your concentration is going to equal your formal concentration. Not all of these problems are going to be like that, so it's a good practice to make sure you put your minus X there, and then just solve for the concentrations here. If you have not ever done an ICE table, this is how that's going to look up. You're going to have the concentration of your reactants on one side, your initial change, and then at equilibrium. And then your reactants are going to be over here. So H plus and then Z minus. So our initial concentration of our acid is 0.0026 molar. And then our initial concentrations here are 0 and 0. We're going to subtract unknown amount because we aren't really sure how much it dissociates yet. And this amount that it dissociates is going to dissociate into H plus and Z minus. So we're going to add X here. And then at equilibrium, our concentration is going to be the 0.0026 minus X. And then here it's going to be X and X, which we're going to feed in to right here to get the expression that we're going to solve for. This is going to take up a bit more space than what he actually gave me to work, so I may end up moving this to a different sheet of paper. Alright, so our Ka value is 8.6 times 10 to the negative 7, and we're going to set that equal to x squared, because we're multiplying these together, over our concentration here. Alright, and remember we've already said that because this x, like this Ka value is smaller than 1 times 10 to the negative 4, we can discard that x. So we're just going to put 0.0026. And we're going to solve for x. It's easier if you actually do all your algebra to get the x alone before you sub in the numbers. But we're just going to go for it because I've already written it down. Alright, so I plugged those numbers into my calculator and I got an x value of 4.7286. Now remember, our x value is also our hydrogen ion value. So we're going to plug this into our pH equation. If you'll remember, pH is equal to the negative log of our hydrogen ion concentration, so that's going to be 4.7286, and I am keeping more significant figures than is strictly necessary, and I'm going to round at the end, and that way that just decreases the amount of errors that you have. And when I plug that into the calculator, that gives me a pH is equal to 4.33. And that is our answer for part A. Now, the fraction of dissociation for this same reaction, okay, is part B. What is the fraction of dissociation? So our alpha formula is going to equal the concentration of our hydrogen ion over the formal concentration. Alright, so we've got our x value already right here. So we're just going to carry that one down, and this is going to be 4.7286 divided by our concentration, which is 0.0026. And we're going to get our answer. Okay, so I actually did not write the times 10 to the negative 5 here on this alpha concentration, and that does make a big difference. So let's key this in to the calculator. Alright, and this is going to give us a value of 0.0182 technically, but we're going to keep with our two significant figures, so our alpha value is going to be 0.018 there. And now we're going to look at our value for KB. Now we have to go all the way back up to the first part, because the easiest way to find KB is if you remember that Ka times Kb is going to equal Kw. So we're going to solve this for Kb, and we're going to see that Kw divided by Ka is what we're looking for, We're going to feed in our numbers. KW is 1.0 times 10 to the negative 14. And we're going to divide this by 8.6 times 10 to the negative 7. All right, and that is going to give us a value of 1.16 times 10 to the negative 8 as our KB value. And then we're going to use this KB value to find the pH of the solution in the base. Now, the way that Dr. Butcher does things on these quizzes is if it is all 4 parts of the same number, it's all in the same system, and so you can make a lot of assumptions based on that. All right, so what we're going to do is we're going to start with our KB value. We're going to start with our KB value. We're going to put KB is equal to, my paper sliding around, the concentration of our, all right, it's going to be the concentration of our HC plus and our OH minus. And I always find that when you're doing stuff like this with the bases, when you've been working with acids, sometimes it's good to write the dissociation reaction, which in this case would be NaZ plus H2O, and that's going to give you, your H is going to go with your Z. Remember, sodium is a spectator, so it doesn't actually participate in the equilibrium. It dissociates, and then it's just kind of there. So that's going to be Hz plus OH negative. All right, and now we're going to go back to our equation here. So KB, and then this is going to equal the concentration of our NaZ minus, oops, getting out of the film, minus our X value. All right. And again, we've got a KB value that is less than 10 to the negative 4, so we're just going to get rid of this little guy here. And then we're going to say KB is equal to X squared over F, because remember our concentration is F. And then we're just going to sub in some values and then plug it into the calculator. All right. So my paper is sliding all over the place. 1 times 1, 6. All right, this is going to give us an X value of 1.83 times 10 to the negative 5. And then when we calculate this, we're going to remember that X is equal to our hydroxide concentration. So when we plug that into our POH formula, we're going to get that our POH is going to be equal to 4.736. And then we are going to take this POH and we're going to subtract it from 14 in order to get our pH. So 14 minus 4.736, and that is going to give us 9.26 as our pH. So that is the quiz, and I know this was a really long video. Sorry about it, and please let me know if you have any questions. Thanks.